looking at synthetic division, which hopefully you learned in Algebra 2. And so we're doing it again. You will need your calculators because we will do stuff with calculators. Synthetic division and your calculator are fun friends. Okay? So we are just interested. All right, so this is section 2.3. You will be having a test soon. I think it's on sections 2.1, 2.1 to 2.4. So getting close. We need to do 2.4 still, and then maybe it's through 2.5. I can't remember. I have to look. I don't know. Make sure you're staying on top of stuff. Synthetic division. Are you still writing down the problems? All right. Here we go. Example 1. Use synthetic division to divide. Use synthetic division to divide. The first group of problems you have are just looking at the different notations. So you can see we have different notation here. Yes. Thank you. Okay. Synthetic division to divide. She and I are really good friends. We share tools. That's what grown-ups do. Anybody drop down motor saw? Sure. All right. So the first group of problems today you're doing are just looking at different notation. We are dividing one polynomial divided by another polynomial, so we could use the division symbol, or we could use a big division bar like this, and they mean the same thing. We want to write the answer in the form d of x times q of x plus r. D of x represents the divisor, D-I-V-I-S-O-R, the thing that is doing the dividing, so this represents your divisor. Q, what do you think Q stands for? Quotient, very good. Quotient is the answer that we're going to get to our division. And then R for remainder. And I'm really doing this just so you know those words, right? Okay. The thing that we originally started with is the dividend, the thing we're dividing into. Okay, dividend. All right. So right now, when I look at the divisor here, we're dividing by x minus 3. I call that a factor. It looks like a factor, doesn't it? Okay, it's a bubble. Okay. It looks like a factor. And when we use synthetic division, for synthetic division, we need to know what the 0 is, essentially. I use the term 0 loosely here. But if we have a factor x minus 3, what's the 0? What does x equal?
3.
Positive 3. Okay. So we use the positive 3 when we're going to be doing synthetic division. So I'm going to take my positive 3. The 0 goes on the outside.
Oh, it's this.
Yes, it's this. You'll remember. And then along the top, we put all the coefficients of our dividend. So we have a 1, which represents 1x cubed. We have the 4, which represents 4x squared. Negative 3 and negative 12. What I need you to be aware of is that we want to make sure that we have all of our powers from highest to lowest. So x cubed, x squared, x to the first, x to the 0. In order for synthetic division to work, you have to have every single term. You can't have any skips, okay? And then the process is this whole combine and multiply, combine and multiply. So we start with a 1, and I'm combining it with nothing. 1 plus nothing is 1. And then we multiply 1 times 3. 1 times 3? 3. We write the result in the next column. And then you combine 4 and 3? 7. And you multiply 7 times 3, 21. Write the result in the next column. You combine negative 3 and 21, 18. And you multiply 18 times 3, 54. Very good. And then you combine, and this is, you get out your calculator because crazy numbers. 42. Very good. Always, 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 the last number is the remainder. All right, so this is a remainder of 42. This 1, 7, and 18 is the quotient in simplified form. So I'm going to talk about what that really is. We started with a 1x cubed, and what we're doing is we're dividing out an x. We're dividing out an x, and if we're dividing out an x, we're no longer at x cubed. What are we down to? X squared, and then they count down from there. And so what we have here is this division is equal to divisor. What's my divisor? Right here. This is our divisor. The actual factor that we're dividing by is x minus 3. And then what's the quotient?
X squared plus 7x plus 18.
Good. X squared plus 7x plus 18. And then what is the remainder? So plus 42. So divisor times quotient plus remainder is this form right here. Synthetic division only works when we have an x to the first power. It doesn't work all the time, but for what we need it for right now, it's really, really good. Melanie?
I'm sorry, 54.
54. 18 times 3.
Oh, okay.
So it's the same combine and multiply. Combine and multiply is over and over and over.
So the factor has to be x to the first, right?
Yeah, so linear. It has to be x to the first power. It doesn't work if you have like x squared. Okay? If you're dividing by x squared. Yeah. So it doesn't work all the time. But we can do some interesting stuff here. Dividing by this factor x minus 3 halves. But before I do that, what's wrong with my dividend? It's missing something. 3x cubed minus 4x squared. What's missing?
X.
A 0x. You must fill in the missing term, ladies and gentlemen. Synthetic division depends on having all of those terms. It doesn't work otherwise. All right? So make sure that you fill in anything missing. All right, from the highest to the lowest, you want everything in between. Okay, and now I can do synthetic division. If my divisor is x minus 3 halves, what's the 0 that I'm going to use? Positive 3 halves, yes. So we're going to use 3 halves on the outside. And bless you.
Thanks.
Write all our coefficients along the top. 3, negative 4, 0, and 5. And again, the process is combine and multiply. 3 plus 0 is 3. And we multiply. What's 3 times 3 halves?
9 halves.
9 halves. And this is where I just don't really care enough. So negative 4 plus 9 halves gives me 0.5, which is also 1 half. And you could math frac that if you needed to, right? So use your calculators. What's 3 halves times 1 half? 3/4. Very good. Straight across when you multiply, straight across. 0 plus 3/4 is 3/4. And 3/4 times 3 halves. 9/8, and then there again, I just don't care. 5 plus 9/8, 6.125, and I'll math frac that and get 49/8. All right, so use your calculators. What's the remainder? 49/8 is the remainder. All right, and so what's our divisor? X minus 3/2 is the divisor. And what's the quotient?
3x squared plus 1/2. 1 3/4. Got it.
Okay, good. So that's our quotient, Q of X right there, Q of X, okay. Plus remainder, what's our remainder? 49/8. Divisor times quotient plus remainder. So synthetic division, pretty cool. You can use do some pretty interesting stuff with it. Any questions on that? Raise your hand if you vaguely remember that.
I know before you even started.
All right, example 2. Use synthetic division to show that X is a solution. And then use the result to factor completely. Factoring completely is my emphasis in this class. We want to be able to see the factors because it's really, really useful and it's easy to check on your calculator. Lots of ways. So factoring, we want our polynomial totally transformed into a bunch of bubbles. Use synthetic division to show that X is a solution. So to show that X is a solution, that's sort of fancy language for also a zero. Okay, to be a solution of a polynomial means it is an x-intercept or zero. All right. If I know that it's a zero, then I also know that it must be a factor. So we've been doing this the past few days. If I know that x equals -3 is a 0 and x equals 5 is a 0, here's -3 and here's 5, I know that they're zeros. What factor did they come from? X plus 3 and x minus 5. So if we know something is a solution, then we know it's a factor. Now, the other thing we draw from that is what it means to be a factor. So my question to you is, what are the factors of 56? 7 times 8, right? There's some others, but that's a good pair. The thing that makes them factors is that when we take 56 and divide by 7, what do we get? 8, remainder 0. Remainder 0 is the key. If we have a remainder of 0, then we know it is a factor. And if I know it's a factor, then I also know the zeros. So knowing something has a remainder of 0 tells us a lot of information. This first polynomial here, they're telling us that x equals -2, possibly. What information is that? So maybe the factor is x plus 2. So you're telling me this is a 0, possibly. That's what they want to know. Use synthetic division to show that it's a solution or to show that it's a 0. Well, if it's a 0, then its remainder is going to be 0 as well. It's kind of interesting. So here's our 0. We're going to use that in synthetic division. 3, 2, 1, 0. I have all my powers there. So 2, 1, -5, and 2. And I'm going to go ahead and do some division here. 2, bring down the 2 and multiply. 2 times -2 is -4. Combine. Is it in bubble form?
It's 0.
Oh.
It's already written as a 0. Okay. Multiply. +6. Combine. 1. Multiply. Combine. 0. Remainder 0. Remainder 0 means we have a factor. The 0 is -2. What's the factor? X plus 2. Very good. -2 is the 0, and the factor we would rewrite as x plus 2. And what's our quotient? 2x squared minus 3x plus 1. So there's our quotient, q of x. Divisor times quotient plus remainder 0. I don't need to write that. Now we want to factor completely, which means I want to try and factor this trinomial here. You'll notice I wrote f of x, and that's really important because I'm not changing anything in this polynomial. It's the original polynomial. I'm just breaking it down into bubbles, breaking it down into factors. Okay, they are identical, which is also a big hint because they should be graphically identical. All right, which I'll show you in just a second. We're going to double bubble here. First times first has to be 2x squared. What times what is 2x squared? 2x plus, times x. And then last times last has to be +1. What times what is +1? -1 and -1. How do you know if you did it right? Check the rainbow. All right. So my rainbow here is -2x and a -1x. And when we combine those, we get -3x. All right. This is factored completely. It's factored completely when I have all my x's factored as far as I can go. X to the first power, hopefully. Sometimes it doesn't work, but that's good. Now, how do I know I did it right? You graph your original function, 2x cubed plus x squared minus 5x plus 2. And you'll notice they both say f of x, which means they should be equal to each other. They're both labeled the same. And I'm going to go ahead and type in x plus 2, 2x minus 1, and x minus 1. If you graph both of these functions, what should they look like? They should be the same. And you'll notice that's probably not what your graph looks like, but they're the same thing. Nick, is your hand up?
Yeah. So why is it x squared instead of x to the third?
Why is that x squared?
Yeah.
So it started out, this 2 represents 2x cubed, right? From right there. We're dividing out, technically, we're dividing by x plus 2. So we're dividing out an x, or reducing the x. So it's no longer x cubed, it becomes x squared. So all of these, x squared reduces by an x, okay?
How do you make the remainder? Like for the last one, I was just looking at it.
The remainder?
Yeah.
On the last one?
Like the first one.
I used my calculator.
Oh, for the first one.
Oh, for the first one.
8.
-12 plus 54.
Okay.
Okay. Letter B is quite interesting. A little bit different. Kind of crazy. I thought it was really interesting. So here they're asking, is x equals -5 a solution, or is it a 0? Okay, is it a 0? Question mark. I'll know it's a 0 if it has a remainder of 0. So I'm going to use that in my division here. Negative radical 5. I'm going to put my coefficients 2, -1, -10, and 5. There's no missing terms there, so that's good. Now this is where it gets real interesting. I'm going to bring down my 2, and then I'm going to multiply. What do you get when you multiply?
2 out of 5.
-2 radical 5. Very good. -2 radical 5. And how do you combine -2 radical 5 and a -1? I don't think you can, because you can't. -2 radical 5 and a -1 just stays a -2 radical 5 and a -1. Craziness, right? All right, so now I need to multiply. Watch what happens here. This is interesting. Negative radical 5 times -2 radical 5 minus 1. We want to multiply. What is negative radical 5 times -2 radical 5?
2.
10. 10 is correct. Why 10?
Because the radical.
Yeah, radical 5 times radical 5 is 5. Oh, no, that whole term, yeah. 10. Negative times negative is positive. 2 times 5. All right, and then negative radical 5 times -1. Positive radical 5. Right? Negative times negative is positive. So we get 10 plus radical 5. All right, what's -10 and 10 plus radical 5? Radical 5. Very good. What is radical 5 times negative radical 5? -5. And 5 and -5 makes 0. Wasn't that crazy?
Yeah.
Well, here's the crazier part still.
Factoring it.
Factoring it. Yeah, so I'm going to take my function. This happened to be a 0. What's its factored form? X plus radical 5. Here's our quotient. I'm going to write that as a polynomial. 2x squared plus, I'm going to use the parentheses here, -2 radical 5 minus 1 times the x. And then plus the radical 5. That's the remainder of 0, which I don't need to write. Now here's the really interesting part. I've got to try to double bubble that. It does. It does double bubble. What? Okay, watch. Are you ready for this? This is the
2x and x.
all right. Good. First times first has to be the first thing. What times what is 2x squared? 2x times x. Very good. Now last times last has to be radical 5. What times what is radical 5? Radical or 1 and radical 5 would be fine. So -1 and negative radical 5. How do you know if you did it right? You check the rainbow. Let's check that rainbow. 2x times negative radical 5 is -2 radical 5 with an x. -1 times x is -1x. What happens when you distribute your x there? Does it work? Yes, it does. That's very cool, right? All right. This is completely factored. I just thought that was neat. That's why I did that. All right. All right. All right, one more. Yeah. Example 3. Here's where you need your graphing calculator, friend.
Is there a synthetic division thing on the calculator?
No. Use a graphing utility to approximate a 0. Use the 0 and synthetic division to factor the polynomial completely. Again, our ultimate goal here is transforming this polynomial into a whole lot of bubbles. Okay? We're just rewriting it. We're not changing, we're not adding, we're not subtracting, we're not solving. All we're doing is changing it from one form to factored form. which means when you're done, again, the original and your factored form should be graphically identical. You can check them all using your calculator. Now, I have this lovely polynomial here, but they didn't give me any helper zeros. Now, before calculators, there is actually a way to figure out what those zeros are. It's called the rational root theorem. You can look it up if you want. But we're going to use our graphing calculator to help us out with some zeros. So 2x cubed plus x squared, whoops, 2x cubed plus x squared minus 5x plus 2. Anytime you use your calculator, you're going to make a little bitty sketch. All right, here's my little bitty sketch. Looks something like that. It came below the axis, so I'm going to, whoop, there we go. All right. When I look at this little bitty sketch here, what's the first zero you look at? What's the first one you're noticing?
Was that like 5 or 1?
0, 2.
Negative 2?
Negative 2.
Yeah? Okay. Negative 2 is the first one I noticed. I don't want to waste time, so how do I check to make sure it's a 0? Trace. I'm going to use trace and check negative 2. And yes, it has a y value of 0, which makes it a 0. So I know that negative 2 is a 0. I'm going to use that 0 in synthetic division to help make this something I can factor. I'm looking at these 4 terms and thinking to myself, hey, can I factor by grouping?
Would you have to put a graph? Or can you just look, trace and look at it?
I'm always going to say make a little sketch. If you use your calculator, make a little sketch. Always. I can't do factor by grouping. It's not going to be, I always want to try to do it by hand first, but if it doesn't work, then we use our calculator. 2, 1, negative 5, 2. Bring down the 2 and multiply. What do we get? Combine. Multiply. Combine. 1. Okay. Multiply. Combine. 0. Remainder 0. Yes, we knew that already. So now the 0 is negative 2. What's its factor? X plus 2. What's our quotient? Good. And then we're going to double bubble that. First times first has to be 2x squared. What times what is 2x squared? Good. And then last times last has to be the last thing. What times what is positive 1? Negative 1 and negative 1. How do you know I did it right? Check the rainbow. It works. I promise. How to use your calculator to check? Put in both of them. Put the answer in Y2. Put the original in Y1. The graphs should match. All right. What else can you check? Because I already have the original in here. If I know the factors, what's the 0 for this bubble? Positive 1/2. So I'm going to trace and do positive 1/2. 0. What's the 0 for this bubble? 1, 0. All right. So since I already had it in there, I know that that's a perfect factorization. Okay. Lots of ways to check these, which is very, very cool. All right. The next polynomial is super big. It's a 4th degree polynomial. Craziness. So I'm going to start by typing it into my calculator. 8x to the 4th minus 14x cubed minus, 71, x squared minus 10x plus 24. Watch this craziness. Here we go.
Zoom, zoom, zoom.
Yeah, right? Zoom, 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 zoom. Okay, so it's a bunch of lines. No, it's not. What should it look like? Kind of like a parabola, but it's 4, 3. It's actually more like a W. I'm going to change the window. I'm noticing I really don't need to go beyond negative 5 and 5 maybe. I'm going to change my window negative 5 to 5, And I want my y values to be much larger. I'm going to go like negative 50 to positive 50. Maybe 100, I don't know. But I'm going to change my window and make it a little sketchy.